Welcome to Brain Vision.
16.10. So we're given the equation for a transverse wave on a very long string. Y equals 6 sine of 0.02 pi x plus 4 pi t. Units on these constants are omitted for brevity, but we're told that y and x are measured in centimeters and time t is in seconds. So we can figure out units for our answers. And there's a number of things that we're curious about, or at least that we're told we need to find. Maybe we're not so curious, but so the first one is the amplitude. Now this one is quite simple. The amplitude is, of course, just the maximum value that the displacement takes. We know that the sine function has a maximum value of plus or minus 1. So the amplitude is just going to be what's out here in front of it. So that's going to be 6 centimeters. Next, we'd like the wavelength. So lambda, the wavelength, is 2 pi divided by the angular wave number. The angular wave number here is 0.02 times pi. So just putting that in, we get that the wavelength is 100 centimeters. For the frequency, we know that the frequency is the angular frequency divided by 2 pi. The angular frequency here is 4 pi. So the frequency is going to be 2 hertz. So the wave speed obeys the relation that it's equal to the product of the wavelength and the frequency. And we just found both of these things. So this is going to be 200 centimeters per second. Now the direction that this propagates, we know that for a wave propagating in the positive x direction, there's a negative sign in front of the omega t. And since this is reversed, you can convince yourself that that means it's going to be traveling in the opposite direction. So we have a positive omega t here, so you can think of this as sort of, in order for these to compensate for each other, so that you're at the same amplitude, say, as it, or not, the same displacement as the wave propagates along the string, so you're following a point on the wave. In order for them to compensate for each other moving in the positive x direction, they have to have opposite signs. And so in the negative x direction, they'll have the same sign. So this goes in the negative x direction. So the maximum transverse speed, so the transverse speed is going to be well, the transverse speed is the time derivative of this. So you get an omega y sub m times a cosine, and again the cosine has a maximum value of 1. So you just ignore that, or set it equal to 1. So this is y sub m times omega, or 2 pi f times y sub m. And so the maximum transverse speed is 75 centimeters per second. Either way you want to do it, we already found f. Omega is given to us as being 4 pi radians per second. So for here, this last part, we just plug in these values for x and t. So y is 6 times the sine of 0.02 pi times our 3.5 centimeters plus 4 pi times our 0.26 seconds. And so then just evaluating this, we find that we have a displacement of -2 centimeters at this point along the string and at this time.